Multimodal large language models combine text and images, enabling incredible capabilities. But they also create new safety challenges. Attackers can use jailbreak images, models can misinterpret visual context, and safety alignment becomes exponentially harder. ReFrame offers a solution that works on deployed models without retraining. Multimodal models face three intertwined safety problems. First, cross-modal jailbreaks. Attackers embed harmful intent in images and use subtle text to evade detection. Second, safety awareness failures. The model may not recognize when an image contains sensitive content. Third, overrefusal. Models that are too defensive refuse helpful requests on sensitive topics like medicine or chemistry. Current approaches have critical limitations. Many require expensive safety fine-tuning after deployment. Others need access to internal model states like gradients or attention maps, which is impossible with closed-source models like GPT-4 or Gemini. And many only focus on jailbreak defense, ignoring safety awareness and overrefusal problems. ReFrame identifies two critical obstacles that cause safety failures. First, utility dominance. The model prioritizes helpful responses over safety concerns. Second, reasoning inertia. Once the model starts reasoning down an unsafe path, it struggles to redirect. These insights guide a solution that works at test time using local evidence generation. ReFrame uses two local agents working together to safely redirect the downstream MLLM. The evidence generation agent analyzes the input and generates two evidence cards, a risk card that identifies potential harms and a utility card that identifies legitimate needs. The rewrite-hand routing agent uses these evidence cards to rewrite the prompt and decide whether to include the image. The evidence generation agent constructs two cards. The risk card identifies potential harms, hidden intents, and suspicious patterns in the image and text. The utility card preserves the legitimate need and helpful intent. By explicitly reasoning about both sides, the system avoids false positives that cause overrefusal. Based on the evidence cards, the rewrite-hand routing agent makes two decisions. First, it decides whether to preserve or rewrite the prompt. For routine requests, it preserves the original to maintain utility. For suspicious requests, it reframes the prompt to remove unsafe intent while maintaining the legitimate goal. Second, it decides whether to discard or keep the image. The safe proxy prompt and image routing decision are then sent to the fixed downstream MLLM without any modification to it. The model receives a reframed input that emphasizes safety while preserving the user's legitimate needs. This approach works on any multimodal model, whether open or closed source, because no internal modification is required. Consider an image with text that's been horizontally flipped, hiding harmful intent. Accompanied by an innocent prompt like how to make the kite fly higher. This is a classic jailbreak. ReFrame's evidence generation detects the mirroring, extracts the true harmful title, and generates a risk card warning about the hidden intent. The rewrite agent then blocks the image or reframes the request toward safe alternatives. On the safety benchmark testing jailbreak defense, ReFrame achieves 97% safety on GPT-4. 1. A massive improvement over the base model's 82%. This is even better than the previous best method, EchoSafe, which achieved 66%. On the MML mirror benchmark testing safety awareness, ReFrame jumps from 36% to 84.08%, a massive gain of 61 percentage points. This shows the model now recognizes hidden content in images, addressing a major gap in standard multimodal models. On the Moss bench dataset testing sensitive domain requests, ReFrame preserves 74.76% utility while maintaining 99.73% safety. This shows ReFrame successfully avoids overfusing legitimate medical, legal, and chemistry questions. The model becomes both safer and more helpful. ReFrame can pair the evidence generation agent with different local models, using QN3VL8B locally while routing to GPT-4. One achieves excellent results, 99.80% safety on mirror jailbreaks and 92.12% safety on the CUO benchmark while preserving 94.76% utility on sensitive domains. The approach is model agnostic. ReFrame works not just as a wrapper around GPT-4, but also when applied to large open-source models. Using QN3. 6-35B directly with ReFrame achieves 97% safety on mirror jailbreaks, 80% on CUO, and 100% on Mossbench safety. ReFrame improves any model it touches. ReFrame has 4 critical advantages. First, it requires zero retraining. It works on deployed, closed-source models without modification. Second, it addresses all 3 safety problems: jailbreaks, safety awareness, and overrefusal. Third, it's lightweight. Evidence generation runs locally. Fourth, it generalizes across models and benchmarks. ReFrame opens several research directions. Future work could explore more sophisticated evidence generation, adaptive routing strategies for different model behaviors, and extensions to longer multi-turn interactions. The framework also motivates research on interpretable evidence representations for other modalities. ReFrame demonstrates that multimodal safety alignment doesn't require retraining or internal model access. By using evidence-guided prompt rewriting and image routing at test time, it achieves state-of-the-art results across jailbreak defense, safety awareness, and utility preservation. This approach represents a practical, generalizable solution for deploying multimodal models safely.